So 11.2 is all about circle area, whereas 11.1 was about circle's circumference. So the first thing is the area of the circle. So we're going to put down the formula here. So the area of a circle, this should be familiar. Area is equal to pi times the radius squared. Okay, and then that's measured in inches squared, centimeters squared, feet squared, whatever that is. So that would be units. It's like inches squared or something like that. Okay. Okay, so in terms of pi, or exact area, so what you're going to see in the directions is in terms of pi, and we kind of talked about that yesterday as well, but everything that we give as an answer in the directions, it might say leave your answer in terms of pi, or it might say find the exact area. So what that means is your answers are going to be left with a pi in the answer. So pi should be in your answer. For example, if my radius was 3 squared pi would be 9, so my answer would be 9 pi, and then something like centimeters squared would be your answer. So that would be an exact answer, or an answer in terms of pi. If you had an answer like 27.24 centimeters squared, this is not in terms of pi, okay, because you don't see a pi in the answer. What if it was 27.24 pi? Then we need to go back to our calculator and use that fraction function of the calculator and ask our calculator to give us a fraction instead of a decimal. When we use pi, there should not be decimals within your answer. Sometimes it's impossible to give a decimal if you're working with like square roots or something like that. So in that case, we would not leave the answer in terms of pi. All right. So this one says, find the area of a circle with a radius 9 centimeters. So our area would be pi times 9 squared. So that's 81. So our exact answer would be 81 pi centimeters squared. Okay, pretty straightforward. So a lot of times we deal with area prior to getting to high school, so that might seem familiar. Okay, so this one says find the radius if the area is 121 pi. So the reason I keep putting area equals is that sometimes the number you have in the problem is going to replace the area instead of replacing the radius. Now you may already know the answer for this, but just humor me and let's go through the process here, because what if it's a number that you don't know? Okay, so 121 pi would go here. 121 pi is equal to pi radius squared. And right here is where you can tell why we leave things in terms of pi, because here the pi's can cancel out. And so you're left with 121 is equal to radius squared. Okay? So then radius would be 11. So another question that you might be asking is, what about this feet squared? Where does that come into play? How come that didn't go into the formula? Well, the feet squared just tells you that when you have the radius equals 11, the radius is actually equal to 11 feet. So that's where that can come into play. That does not need to go into your formula as you're solving. So the sector area, so a sector, think of it like a slice of pizza. So if this was my whole pizza, a slice of pizza might look like this. That is a sector. So a sector is a piece of the entire area of a circle. Okay, so it is part of a And more importantly, it's a very specific fraction of a part. So in the formula, so it's a part of the area that's very as simplified as we can write the definition, but it's a very specific part. So in the formula, you're going to see the part, and it's very similar to the formula we saw yesterday when we were doing arc length. Okay, so it's going to be the measure. Hopefully you remember this from the previous section. The measure of the arc, so that's a degree measure, divided by the total, 360 degrees, and then we multiply it not times 2 pi r today, but times pi r squared because we're dealing with area. And there's your formula. So you can kind of see how it's very similar to what we were doing in the previous section. Okay, so let's try some examples with that formula. Okay, let's zoom in so we can get a better picture here of each problem individually. Okay, so the first one. This is showing you 90 degrees at the center, which means that the measure of this arc between A and B is going to be 90 degrees. Okay, so it's going to be 90 degrees divided by 360 times pi 6 squared. Okay, so we talked about before using your calculator or using your Desmos app to simplify this equation, or you can simplify it by hand. So if we're simplifying it by hand, 90 divided by 360 is 1/4. That's 1/4 of the circle. So we have 1/4 times 6 squared is 36 pi. So now we have to take 1/4 of 36. So that part right there, we're just basically dividing 36 by 4, which is 9. So my answer here would be 9 pi for this sector's area. So 9 pi centimeters squared. Okay. Now again, if you're using the Desmos app, which is pretty slick, or if you're going to use your calculator, you can just type that in, right? 90 divided by 360 and multiply that by either 6 squared, or you can just times 36 and it'll tell you the answer is 9. Okay. So over here on the side, you can see my answer was 9. Notice I did not put the pi in the calculator. So if you're going to use your calculator, leave the pi out when you're typing in all of your numbers. Okay. Let's go to the next one. Okay. So here we go. 60 over 360 times pi 10 squared. And if it helps to remember not to put the pi in, maybe you put the pi just kind of at the end there. That's okay. You can do that. So if you're reducing this by hand, 60 divided by 360 is 1/6 times 100 pi. Now 100 doesn't divide by 6. So we talked yesterday, well, what if it doesn't divide? Then you need to leave it as a fraction. So it's 100 over 6, which can be reduced to 50 over 3. Okay, and with the Desmos app, that's super slick to do. And remember, if you have one of these graphing calculators, which you're going to need next year anyway, and you're typing this in, so 60 divided by 360 times 10 squared, it does give you a decimal, which you can see there. But if you use the math button, which is the third one down on the left, so math is right here. The first option that pops up is fraction. So I'm going to hit enter, enter. And there's my simplest fraction, so 50 over 3. We don't want the fraction part to be the part that makes you get it wrong. So I wanted to show you as many tools as possible to get that answer correct. So you can do it out by yourself. That's here. You can use the Desmos app on your phone, or you can use a graphing calculator if you have one. Get used to using a graphing calculator if you have one, just because you're going to need to use it next year in Algebra 2. Okay, last one on this row here. Okay, so this is telling you the measure of the arc in a very interesting way here. So it's showing you 3 equal parts. So 360 divided by 3 is 120. All right, so if you were using the formula, be 120 over 360 times 24 is our radius, squared pi. But it's also showing you that this is one of 3 equal parts. So instead of doing 120 over 360, you could have just jumped right to 1/3. 1/3. And then multiply that times 24 squared, which most of us don't know that off the top of our head. So 24 squared. Here's where you have to be careful, because it is super tempting right here to multiply 1/3 times 24. So 24 divided by 3 is 8. 8 squared is 64. We can't do that. The squared part has to come first in the order of operations. So I have to square 24 first before I divide it by 3. So 24 squared is 576. And then I can take 1/3 of that, or I can divide that by 3. Okay, so 576 divided by 3 is just 192 pi. Slide that over. Okay, so to make this the perfect answer, I should probably add in inches squared for this one and feet squared for this one. There we go. Okay, last type here, example 3. So example 3 at the bottom, hopefully I don't make you sick doing this real fast. So example 3, so this is asking you to do something that's a little bit different. It's giving you the area of this sector, and it's wanting to know what is the area of the whole circle. Okay, so here's what we're going to do. I'm going to start with the formula. So the area of this sector is the measure of the arc over 360 times pi r squared equals the area of that shaded part. Okay? This area, see how it's not in terms of pi, so we don't want to leave ours in terms of pi. This area goes right there. This 100 is the measure of the arc. And what we are looking for is the area of the whole circle. So I don't want to know what r is. I don't know what r squared is. I don't want to know what pi r is. I want to know the whole thing. Okay, so when we substitute these things in, I'm looking for 100 over 360 times, this is what I want to know. So if you wanted to, you could just put a big X right there, because that's what I want to know. Equals 17.46. Okay, so if you're really good at fractions and dealing with fractions, do you know how to get rid of this? Okay, there's a lot of different ways to do it. Some of you like to do it all at once. Okay, so if you like to do it all at once, then what you would do is you would multiply by the reciprocal of this fraction. So we would multiply both sides by the flipped version, the reciprocal of this fraction, and then that would get rid of it, and that would give our answer. So if we multiply both sides by the reciprocal, boom, we're done in one step. Okay, another way is you could just multiply by 360 and then separately divide by 100. But if we can do it all in one step, let's do it all in one step. Okay, so we're going to go 17.46, and we'll multiply that by 360 divided by 100. Okay, and some people say to me when we're doing this part, how do I put a fraction into the calculator? My answer is you don't really, especially if you're using a graphing calculator. So I just use the division symbol to do the fraction part. So I did 17.46 times, and then here's my fraction, 360 divided by 100. And there's my answer. The area of that whole circle is 62.856. Now that is not in terms of pi, but they didn't give us an answer in terms of pi, so ours won't be in terms of pi either. So the circle's area is 62.856 meters squared. Okay. Let's slide on to the next one and talk this one over. Okay, so my measure of my arc is 175. 175 is so close to 180, right? And 180 is going to be half of the circle. So basically, if this half of the circle is 39, which is like almost 40, my answer should be for the whole circle close to 80. So I'm just kind of using some basic background knowledge to kind of guesstimate what my answer should be. And then I'll work through the problem and see if my answer makes sense. Remember that this right here, this pi r squared, this is what I'm trying to find. So that's like my x. So what you're trying to get rid of on both sides, you're trying to get rid of this 175 over 360. So to get rid of it, I'm going to multiply by the opposite or upside down or reciprocal fraction. So 360 over 175. And I'll get my area. Okay, so again, in the calculator, I'm going to go 39.52, I think it was. Is that right? 52, yep. Times 360. And again, how do I put this in? You're just going to go 360 divided by 100. That's not right. That was the last one. Sorry, 175. And it's 81.2982. So it doesn't say how many decimal places to go to. So what do? Well, if you're given an answer to 2 decimal places, then you should give your answer back to 2 decimal places. So we'll go to 2 decimal places, which would actually make this round up, which would be 81.30. That would be our answer for the area of the circle, inches squared. Just kind of a rule of thumb, if they don't tell you how to round, or if there's not a common rounding for it, however it's rounded in the problem, that's how you can give it back. Okay, so last one. This one's kind of tricky because of the fact that the shaded area is 20.89 and the shaded area is all of this. So it's actually not going to be 78 degrees that we use. It's going to be 282. So this arc is going to be 360 minus 78, which is 282. Sorry about that. 360 minus 78 is 282. So 282 is what I'm going to use in the actual problem. So 282 over 360 times my circle area gave me the answer 20.89. And now I'm going to solve for my pi r squared. I want to know what the area is for the whole circle. So I really just need to get this little piece right here alone. So to get rid of a fraction, you multiply by the flipped version of the fraction, which is 360 over 282. So I got, again, going to 2 decimal places, I got an answer of 26.67, because I rounded up, and then that would be feet squared. Last part here is there's just a couple of problems at the top of the next page before we jump into 11.3. And 11.3 is going to be over 2 sections, so over 2 days. So we'll only make sure that we cover it over 2 days because it's a pretty big section that we have to really take our time with, okay? This one says find the area of the shaded region. So this is kind of like a donut where it's like a big circle and then the little circle is cut out of it, okay? So the big circle, we're just going to find the area of the big circle and then subtract the area of the small circle. So big minus small. So the big circle, it does show you this bracket to show you that all the way from the center to the outside is 4 inches. So my area would be 4 squared pi. Go ahead and leave it in terms of pi. Minus. Now the small circle. So if I just did this part, 4 squared pi, that would give me this entire circle. Okay, but I don't want the whole circle because I want this center part cut out of it. So to cut it out, that's the subtraction part. I'm going to cut out 2 squared pi. Okay, now this is a little piece of interesting information here because you have 16 pi here and you have 4 pi here. And this is something that you probably don't know yet. When you have 2 numbers that are both in terms of pi, you are allowed to subtract the coefficients. So 16 minus 4, you can do that to get 12. So my final answer here, 12 pi. Okay, we haven't worked with pi a lot, so we don't know that yet. But anytime you have 2 numbers in terms of pi, you can go ahead and subtract their coefficient, the numbers in front, to get an answer. So that's my answer in terms of pi. Probably should throw in an inches squared. Squeeze that in there. Okay, next one. Okay, so this is a square. It's showing you, how do I know it's a square? It's showing you the 90 degrees in the corner, and then it's showing you that these 2 sides are the same. So we have a square that's 100 centimeters squared. So again, we're going to do the big minus the small. The big just happens to be a square in this case. So we're going to go the big, which is 100, minus the circle. Now the circle, is not a radius of 10. So we have to be careful about that. The radius of our circle is 5. So we're going to go 5 squared pi. Now, because of what we just did here, by subtracting the coefficients, you might think I can do 100 minus 25, that's 75 pi. And that's actually not true because the number 100 is not a number with a pi in it. So this one, in order to give an exact answer, we would have to leave it just like this. So you could circle that. Or we would have to give a decimal. So the decimal would be 100 minus 25 pi, which is about 21.5. Okay. Sliding this over. Okay, so this is very similar to the problem that we just did, except for it's backwards, where the big one this time happens to be the circle. So our circle, I'm going to slide this in here, would be a radius of 8. Slide that in there. Radius of 8. So we're going to go 8 squared pi. That's going to be the big. So 64 pi. That's the big one. Now, when we subtract the small one, it is a square, but based on what we have here, we actually don't know how to do the area with the diagonal. So you have a couple of options. Option number 1 is you can break this into smaller triangles. So if I broke it into a triangle this way, right here, right? So this would be 90 degrees, and you have an 8 here, and you'd have an 8 here. So in all technicality, you have 4 triangles. Okay, so the area formula for a triangle is 1/2 base times height. So that would be 1/2 of 8 times 8 So half of 64, so this is 64. Half of 64 is 32. And then you have 4 of those. Okay, that's one way to do it. So let me just find what our answer would be. 32 times 4 is 128. Okay, and I know you have some questions right now, but just hang with me. Another way to do that is, hopefully some of you are looking at this and you're seeing you have a right triangle that is an 8, 8, and what would this be for that right triangle? Do you remember? 8, 8, and 8 radical 2. So another option would be to find out that the side length of the square is 8 radical 2. So the area of that square is 8 radical 2 times 8 radical 2, which would be 128. Okay, so that's another way to do it. There's a third way, but that's not a formula that is typically covered here. So we'll leave that one aside for now. Now, the next question you might be saying is, that's going to give us a negative number, Ms. Bosenberg. 64 pi minus 128, 64 minus 128, that's going to be a negative number. But you forget that pi is a number that's bigger than 3. So when I actually multiply that together, go 64 pi in my calculator, and I subtract 128 from it. This is 64 times 3, or a number bigger than 3, and then subtract 128. So that's going to give me 73.1 if I'm just going to one decimal place. Okay, so this could be our answer here. This would be our exact answer because I can't actually subtract those. And that one's in feet, so feet squared. All right, there we go.